Hello,
Hey.
everyone. All three of you. Welcome to
Pretty good.
this month on AWS Consumer Electronics. I'm Brian Tang. I'm a Senior Solutions Architect. And
And I'm Chris Jordan. I'm a solutions architect as well at AWS. Thank you for joining us today. There's two of you now, so it's good to see. There you go,
yeah,
16.
so our stream is about a lot of the work that we do with consumer electronics customers. Like I work with some audio, battery manufacturing, all types of things. And over the course of our show, we've covered a lot of examples of use cases that we've seen and those requirements that we would have around how do we describe these things, how would we build it, and then apply how AWS can be used to complete those things. Yeah, maybe Chris, you could give like
Yeah.
a rundown of some of the things we covered. Hi, Pratik. Welcome back.
Yeah, welcome back, Pratik. I remember you from a lot of episodes actually. So yeah, so as Brian had mentioned, I mean, we've definitely covered a lot, and Pratik, I'm sure you can advocate for us. I think you were on previously, but last episode we really discussed the importance of what it means to be fault tolerant, what it means to have your applications resilient to failure, right? Because it's not it's not just one thing to have applications run, but when you think about any failures or any load spikes, any not like functional requirements that happen along the way, your apps have to resist and recover in a seamless manner. And depending on your org structure, depending on the type of application it is, you may have different tactics in terms of how you deal with a disaster recovery strategy, which we discussed, and like how highly available your application or your applications within your applications are in terms of like fault tolerance. So it's very important to just think back in terms of how DR plays a role into everything that we do, and in terms of like trade-offs for all things when it comes to all our applications, right? So, yeah, that was what we discussed last time. I think this time we're going to pivot a bit and then talk more about video streaming and how the beauty of sort of the big like the streaming different worlds of streaming within the world of streaming. So I know that we pushed this off a couple of weeks back, so we're definitely getting back to it to discuss. So I'll pass back over to Brian. I think he's showing a pipeline up on his screen.
Yeah. I think last week or a couple weeks ago when we were covering a use case, we were talking about an example, a very common one that we can relate to, which is your doorbell that's recording things, and you going into an app and potentially getting notifications, and then clicking and trying to review what that notification, what that video event was referring to, and playing it back. And that's interesting, right? You have some sort of video that's stored as an object in an object store like S3. It gets processed and transcoded, and you can view the finished version of that video through your web application. And one of our viewers had mentioned that what about streaming video? Like how does that work? We tried to finish this one because we also wanted to tie it to our resilience discussion of, okay, once you have like the shell of your architecture up, what are some other things to think about? And we had talked about all different types of ways that you could try to make decisions on how much should you invest in certain parts of the architecture. And those things are RTO and RPO, recovery time objective and recovery point objective. And we went into great detail of how might you plot things on these different axes. And once you've done that, how might you actually update your architecture to take advantage of different design features. And we also talked about the cellular architecture as a design principle that you could use to add redundancy and also be able to make your workload more resilient. And again, like tried to tie it back to, all right, how much should I actually invest into doing this? So today, I actually want to go into video streaming itself. So we're going into this topic. All right. And there's like a couple different ways to do it. Like when you think about it, how does your if you look at like a camera and you log into its feed, how does that just work? And then the other piece is like different would be when you watch Netflix or Prime Video, how does that just work? And there's like two different paradigms. I mean, what other video streaming use cases can you think of, Chris?
Um, I mean, I'm solely focused on like Netflix right now. I can't think of since I've been on my Netflix binge watching lately. But
What are you watching?
oh, I've been catching up on. So I haven't watched the new Squid Games yet, so I've been catching up on that.
Okay,
But
okay.
I have not watched Demon Hunters yet.
Oh,
Like, so
that's a
I
good
need
one.
to, I need to get
You
off on
should
that.
definitely watch it. My girlfriend has the soundtrack playing nonstop. It's very catchy. Okay, cool. So yeah, so we mentioned Amazon Prime or Netflix streaming is kind of a similar use case. But these two are, I would try to put them in different buckets, right? So one is more interactive, right? So you have a client and us, I guess, what would you call it? Master is not like a server. I don't think we call things like a master anymore. Like a master
No,
device. The publishing
like a
device.
primary,
The new
publishing.
is the new paradigm is publishing and like subscribing. But that's slightly different from like I know it's kind of an overlap with pub sub because that's like a different that can be considered like a different thing where you have like a bus and then you publish message to it and then subscribers read off of it. This is more like there's a source that's publishing video data and somebody is trying to negotiate the connectivity and then be able to view it.
Mhm.
The other piece is like a little bit different because think of it as you're not like negotiating the connection and then having like a live connection between the two. It's more like the content is already it was like pre-recorded, right? You're not recording K-pop Demon Hunters live and like giving it to somebody, right? I mean,
Yeah.
in the future with AI, who knows what could happen, but
Well,
like
speaking of that, though, I guess another good streaming use case is the platform that we're on right now, Twitch and other live streaming platforms as well. We can discuss how potentially the different variations of streaming apply to what we're on right now in Twitch.
mm,
So
yeah, other interactive things, yeah, that's great actually, is web conferencing. So web conferencing is your you're basically doing a live feed of me to one or more people and we're all talking to each other. So think of
yeah,
that as like two different paradigms. um okay, so what I really want to focus on today is this first use case, which is this interactive um, low latency kind of communication. I think that's also important. Like um think of it as Twitch is great because you have the illusion that everything is live, but it's like a sub-second uh, latency delay, sub-second delay, I guess, like 100 to 300 milliseconds maybe, but it's like pretty real time, right? Um, Pratik mentioned something. Video
mentioned
KYC.
video cameras.
KYC. Document verification? What do you mean by KYC? I'm not a FinServ.
I would assume that's like know your customer, like document verification for being able to instantly open up a bank account. Yeah.
Oh, verification. I see.
Yeah.
Okay. Oh, I see. Yeah. Like when you have to verify your identity and then they record your face. I think that's good.
Yes, I believe so.
I think when I was taking AWS certifications, they also made me do the same type of record your face from like different angles and then um they would verify my face. when I wanted to take the exam.
Yeah. It's a good one.
Yeah, so low latency, sub-second delay, 100 to 300 milliseconds. But then Netflix streaming, like if there's a delay of serving me the content by like, I don't know, 3 to 5 seconds, it's not a big deal, right? Because I don't care that I'm not like talking to K-pop demon hunters and expecting the movie to talk back to me. I just want it like fed to my face, and that's fine. So
Yeah.
yeah.
And there's a multitude of reasons as to why there is that delay, right? There's like encoding delay, there's networking bandwidth potential concerns like caching, failovers, right? So, yeah, I would say for the most part, Netflix, like we can be fine with like a 5 second delay in terms of content actually being streamed to us on Netflix. So.
Yeah. And just as a guide for people that are viewing, the reason we want to dive super deep into all the inner workings of interactive video is like so you can learn about how this works and then think about how we're going to introduce AWS services that make that a lot easier. Yep. And
Yeah.
also, I noticed the title of our stream is Advanced AI Architectures, but we are consumer electronics, so we wanted to switch the focus to video streaming.
Yeah.
But if you want to talk about anything about AI architectures related, we'll try to shunt that in there. So just let us know.
Yeah. Just throw out any comment in the chat. We'll try to answer anything. But yeah.
For example, it kind of came up when we were talking about interactive, right? So I said, well, you generally don't watch a movie as it's being created, but maybe in the future we'll be able to generate a movie on the fly. And as it's being generated, you're like watching it in real time. That would be super interesting.
Yeah, no, I would love that. I love those aspects of having like a say in terms of where the movie might go next, and like have alternate paths. See
It's
where
like
we're
live. We'll call it live dreaming. You know.
Yeah, you definitely don't want a buffer. I guess less of a buffer in that scenario. So yeah, just relating back to this, it's always a design choice in terms of whether it may make sense to have delays or not, and obviously there's a cost associated to all of these as well. So that's why we'll discuss it as we go on with services as well in terms of why it might make sense to have delay versus not.
Yeah, and then you can think of some other ways to think about the differences between these two is like this is interactive, we're talking back and forth, we're chatting back and forth, and then this is like on demand. I search through a library of videos and then I click one and I get the content delivered to me. And one other thing related to this is the idea of, and I think I'm going slightly off tangent, but I think this is an important point, is adaptive bitrate streaming. And what is that exactly? It's like when you go on YouTube and your Wi-Fi connection is slow, and you're used to watching things in 1080p, and suddenly everything is like super blocky. I don't know how often that happens to you. It happens to me all the time when I'm like on cell.
Yeah, it happens to me all the
annoying.
time. Yeah.
Yeah, and I think something cool to kind of keep in mind is bitrate is the amount of data that comes that is transferred or processed or transferred per unit of time. And then the other bit, like bitrate, but then that's also measured in something called bits per second. And so people kind of talk about this in live streaming all the time of like, oh, what's the bit rate? And that's just basically like, well, this directly impacts like the quality of the stream or the file size that you're able to handle of the video. So you're at a high bit rate, it's great. You get better quality, you can handle larger files, so you need more bandwidth to handle that. So you need a really good connection, which you don't get when you're on the Excella from Boston to New York.
And well, I'd rather the platforms just lower the resolution versus actually not letting you watch it. So I mean, I appreciate that it's quietly altering the resolution, without having to pause or cut off your video.
Yeah, so it's I think that's a good thing. There's always trade-offs.
Yep.
When I want smoothness or I want or performance versus quality, I guess.
Exactly.
Yeah. Or like I want anything at all, right? So
yeah.
Okay, cool. And so we talked about adaptive bitrate streaming a little bit. Maybe we don't have to go too much deeper into this. We just talked about that. This is not related to like interactivity. I think we're going to go into that in a little bit. We could talk about like standards, but that might be all too in the weeds. Quellhorst. What is this? Let us know
I'm
your
unsure
thoughts.
myself. Yeah. Here we go. Oh, okay.
Yeah, I mean, which events did you go to? Summit or
yeah.
did you go to reInvent? And I'm not exactly sure what it means to go hamburger. Is it like to go ham?
Maybe it's like Hamburg, Germany. Maybe. But all right. But we can continue.
Yes, we can continue. All right. So let's talk about this first use case of interactivity and give you a sense of like how complicated it is and then how easy we can make it. Right. So video streaming. Let's just say this is a interactive one. Interactive. Let's see. In this case, what do we have? We have let's say we have the doorbell again, and we have a phone that's like a client, that's an app. You have two devices, and somehow they need to navigate this like universe of things to one, find each other, and then to like agree on how you hand off information. And you can think of it as like there's a lot of gates that you have to go through. You can't just connect two things. Like it's not like your phone and your camera have like a cable that's like attached to each other and they're just like wired to talk to each other. There's like some logical connections you have to make and you have to navigate so that they can reach each other and be able to interact. But before I go in, cool, AWS summits in Chicago, local sessions before COVID. You should go to local sessions after COVID, and I'm sure there's a lot of events that are going on in your area. Sometimes we have, like in Boston at least, we have events that people can attend all the time.
Yeah, I believe I've been to a couple of AWS Loft events, like for AWS startups. So definitely check if there's a hub in your area. Always fun to go to. And I think you can get hamburgers there, hopefully, as well.
Ooh, this is kind of big. How does this look on stream? Look all right?
Yeah, looks good.
All right, we have a publisher, and let's call it a viewer. First, we're gonna show you like what are the nuts and bolts, and then how we can make that easier to navigate. Okay, so somehow there's gonna be in between this universe of things, there's gonna be like network access. NATs you have to navigate in order to talk to each other. So like NATs and firewalls probably that you have to navigate. And so in order to navigate these things, you have to do something called signaling, which is you need to advertise to each other that you exist. And this is how you want to be able to talk to each other. I want to call my publisher wants to call my viewer, or my viewer wants to call my publisher. And there's a lot of components that you have to put together. to make that happen. The other thing is like you have to say what codecs you support. And codecs is just like when you cram two words together, when you're like encoding and decoding. And basically that's just like I like turn a video into one format and then I like turn it into another so that I can process it or whatever. And so that's like that's called negotiation. And I think it's called specifically ICE, which is super cool. Interactive connectivity, is it connectivity? Yeah, establishment. It's really cool. So you're trying to figure out how you can talk to each other and how you can navigate the network paths so that you can talk to each other. AP Mike Lee on YouTube says, "This is awesome. Please send me more like this." How do we put that on? I'm sure we can find a way. All right. I don't know if you can navigate to YouTube and get him. Oh, there we go. Well, he's on YouTube.
Oh, you're on YouTube. Yeah, let me get it. I'll get it for you. Thanks for the comment, Mike.
Okay, so they have to exchange some setup info and then say like what codecs we support, how do I reach you, what ports are open. So you have to get through NAT, and so we have to do some signaling. And usually there's gonna be some sort of standard, and the one that's very common is WebRTC that you use to make it possible. And so I guess you could call it like this is a video gateway and it's using WebRTC, and you're basically trying to establish you're trying to signal to each other to figure out whoa wait, I'm not familiar with this. Oh no, make it stop. Okay. What I was trying to do is, there we go. Yeah. Let's call this, it's trying to signal. Trying to establish a signal. Excuse my signaling.
No worries.
Signaling. And so you're initiating the connection, you need to maintain it, you might have to modify it, you might have to terminate it. And so you establish it through here. And you can do this on both sides. So you have the signal through both sides and do this ICE negotiation. And there's different protocols. I don't think I need to throw them all out here. I think it could be pretty, it might be confusing, it might be too much. But let's just say, at least I'll throw one in here. So there's session description protocol. So that's the protocol that you might use to establish this signaling, so that you can do, I offer something, I answer something, this is the codec I use, this is the details of the media. Okay, but that's not the only thing. Somehow we have to make a connection between all of these things, right? Let me add a line. So I'm going to add this solid green line that says like, that I'm going to throw in the back. I'm going to make it bright green. I'm going to make it really thick so we can all see it. All right. Did it work? There we go. And then
looks great. Yeah.
Something needs to bring all of this together. So these aren't the only actors that are in this place, right? So you also need, there's a couple other servers that you should be aware of. One is called, and there's two of them. So one is called turn, and one is called stun. So what is turn? Well, I should talk about stun first, I think. What does stun stand for again? I'm trying to...
Oh, let me confirm that real quick.
I know what it does. I should probably just Google it.
Stun is session traversal utilities for NAT.
Yeah, so that sounds exactly like what you need it to do. I need to establish a session. I need to go through, I need to navigate NAT. So let's just draw this arrow here and say, I'm going to give it an arrow so we know what direction things are going in. Is that working? Nope. What is arrows? So while we're doing this, I hope we're also learning how to use PowerPoint. That's also the unanticipated secondary benefit of the stream. We hope. Let me know if you're learning things about PowerPoint. Maybe not. Maybe how not to PowerPoint even. You know? So we need to find each other's IP addresses, so we know where each other are, and that you can do through this. Sorry, can you spell it out again? What was it? Session traversal.
Yeah, it's session traversal utilities for NAT.
Yeah, I guess this doesn't sound as cool. So, yeah, or stuffing, but yeah, stun. Find each other. But the problem, and I think this is why turn exists, is that you can't always be able to connect directly through stun. So like what's happening here, like we mentioned, I want to call a publisher wants to call viewer or vice versa. I generate some sort of offer on this session description protocol for signaling, but then I make a series of requests to stun to try to like create this to get the IP addresses. But for whatever reason, sometimes you cannot actually get stun to work, which is why you have turn. And this is actually a relay. So turn, it stands for, again, NAT. Relay for NAT. Traversal utilities. Oh, probably traversal utilities relay for NAT, I believe. I probably should have written this down.
Traversal. Yeah, that was it. Traversal using relays around NAT.
Okay, great. So it sounds like what it does. So like your attempt to use stun didn't really work. And now you go to turn, and turn will essentially help you, because for whatever reason, the NAT was actually like blocking you. You might have like firewalls that might block you from doing that. So you have to fall back to turn, and that will help you. Yeah. And like, if you were to try to build this yourself, you set up your turn server, you set up your stun server, you like find out all the information you need. You implement WebRTC in like a video gateway, and you try to wire it all together. And then you can establish this peer-to-peer interactive communication.
Yep, that makes sense. So you might have more of a stricter, I guess, network at an airport or like a hotel or office, right? So that's potentially where stun might have more restrictions in terms of being able to work. So that's when it reroutes the turn, I guess, to negotiate and find a proper pathway.
Horse wants us to pivot and talk about field programmable gate arrays. I know we have teams that work on blogs for this. That's mostly in the compute team. Kind of looking now. Well, okay, Quillhurst, why do you want us to run a blog on FPGA, and what exactly would you like us to do? I think we can queue that up asynchronously. We do have a lot of former or current embedded device engineers that we work with, so they might be able to follow up in more detail. But I was never a device driver creator, or like to escape the GPU and save power. To escape the GPU. Hmm. I'd have to know more about the use case, but we do appreciate you chiming in.
Yeah, if you can provide more about the use case, potentially we can discuss a bit more in a future episode.
But I think he's talking about using FPGA to avoid using a GPU, but I don't know enough about that to say.
Yeah.
Um,
No problem. Thanks for the input, Clawhorst.
thanks for chiming in though. Stock line go up. Yes, we love that. All right, so direct connection could potentially fail. We want to fall back to this turn relay service. So, and then the turn server is able to relay those requests to the viewer. So it's like, you can think of this as like forwarding the content to the viewer. Okay. And I mentioned WebRTC. I think we could probably just send like the WebRTC resource to people if they want to look at it. It's webrtc.org. And there's like a lot of interesting samples that you could look at of the libraries that are available. Thank you. The capabilities that you can do once you establish a peer connection, and just like looking at this, you can see like change bandwidth on the fly, change codecs before the call, upgrade a call and turn video on. There's like a lot of cool features that you can establish, and you can even see now. There's an article on. Well, I'm actually not sharing it, but they talk about, hopefully now when you see like ice and you see stun and turn, you know what those are. So you know what these are referring to. Okay.
Yeah.
Yeah, you can test it out too.
Yeah, I would say as well, it is important to note that I would assume, having to redirect a turn would add an additional hop in terms of potential latency. So there might be a potential delay there as well. And I'm sure there's additional bandwidth costs as well if the stun fails and has to reroute to turn. So there's always design and architectural and scaling decisions to make when it comes to all things that we're discussing here today. So, and also we talked about HA and DR scenario. I'm not sure if we'll discuss, but it's important to have like a fallback plan as well.
Yeah. And we talked about signaling, which is trying to establish like who you are, where you are, what rules you have to connect. But then once you're actually sending the media, you use another protocol, real time. This one's easy to remember, real time transmission protocol. And it makes a lot of sense because it's real time and you're transmitting it, and it's a protocol. So this is like packets that are sent over UDP because it's just like video. You're dumping a bunch of stuff in. It's not like a web page that has to be, it has to come in this order. And you're sending this RTP over UDP. And so that's how you get video across. And it's navigating using stun and turn so that you get to the viewer. Ooh, there we go. And then so the viewer is able to get these packets and then reassemble them, decode the frames, and then render the audio and video. So that's how you're probably viewing us right now. Well, I guess Twitch is a little bit different because the viewers are not streaming back to us, right? We're streaming one way to them.
Yeah.
It's more of like when you have like a video call with each other, that makes more sense.
Got it. So it helps to keep latency super low in real time as you stream back to each other. Yep.
Yeah. And then this WebRTC business, that's mostly for like, how you view things in the browser. So like when you fire up the Zoom call or whatever and you open it in the browser, I'm sure there's some WebRTC business going on in order to implement some of this, some of the stuff that we talked about. Yeah. I'm going to mention UDP. What do we know about UDP? It's fast. It is connectionless. Is that what the word is?
Connectionless.
Not connectionless, but like, I think of it as just like you're dumping packets at somebody,
Yeah.
and usually it's video or voice over IP or something like that.
Mm-hmm.
Okay. There's other stuff that I think it would be overcomplicated, but there's like encryption involved as well. So you have RTP, but then you have SRTP. So you want to make sure that these packets that are being sent back and forth are also encrypted, so no one's like siphoning off the stream and reading it. So that's something to keep in mind of. UDP does not care. Yeah, it's like not as strict, I would say, as TCP. Yeah. Yeah, back in the day, I remember I played when I was playing StarCraft, and I'd fire up battle.net. Anybody remember the old battle.net? It had like a UDP option or something like that.
I do not.
Yeah,
I'm sure someone in the chat does, though. But
this was like 1998.
That's a good point. I remember when I was studying for one of the certifications, they always associated UDP to like gaming in terms of the way to remember it. So,
Yeah.
But yes, Brains TCP ensures everything arrives correct. It's more reliable, no losses in terms of like the order that things arrive in, right? So yeah, exactly. And then I see a question from Teak. I missed this one. DTLS, SRTP, or any encryption mechanism, the WebRTC mandates it.
I don't know that it mandates it. But yes, you can use encryption. I would probably say you should use encryption. Use SRTP. You need to use secure key exchanges as well. Obviously, like you need to protect your keys and to use those keys for encryption. But I don't know that WebRTC like says you have to use encryption. I'd have to read through, but it gives you the ability. I think it's probably like a shared responsibility type thing. It's like you have all the tools to be able to do this. Up to you to use it, and you should use it. All right. Okay. So now that we talked about all this, and it sounds complicated, what does it look like when you have AWS in the mix? Like, how do we do this? I'm gonna try to keep it in the same diagram. Check this out. I'm gonna make this smaller. Whoops. And just move it over here. And now we can do something on AWS. So let's just say we still have our hardware device. We're encoding with some format. I think what are the latest ones? H.264. Well, I might as well like talk about some of these. H.264. So you have codecs. And what is a codec? We mentioned it's kind of like a format. And you have Apple has its closed standard, which is HLS, I think is what you'll probably often see. And there's H.264 and H.265. So whenever you see HLS, which you probably have, that's like Apple's closed standard, I believe. And it stands for HTTP live streaming. So that's easy to remember. HTTP live streaming. I think I'm adding too much now, but let's just say hardware.
No worries.
I'm getting off the point. Hardware. I said hardcore. Hardware is hardcore. Okay, so you have the device. You need to use you still have to use like a SDK. So there's a KVS WebRTC SDK, and that allows you to do a lot of the function calling and library usage that allows you to interact with those that do the ICE negotiation off the bat. So assume it's the doorbell that we keep going back to. It has through ICE that you're doing stuff with the SDK. You can find the local IP via the LAN. You can find the public IP via done, like we said up here. And you can also have a turn relay, which AWS will provide you with. So you don't have to like set one up. And that's one of the benefits of using AWS. And all of this stuff in the middle between the publisher and the viewer that you would have to think about. I have a service for this called Kinesis video streams. So all of the stuff that we were talking about actually gets abstracted. Yeah, if you're in the audience and you're interested in setting up some sort of or testing out and playing with some sort of demo on your own, like a POC, feel free to do so. And because
so that service, that's essentially running the whole signaling flow, right? So I guess like all the like your cameras, your doorbells, and your viewers, which are the apps, can connect to each other and find each other.
Yeah.
We did have a question actually from Pratik in terms of how do you recommend handling turn scalability and geo distribution for low latency global streaming workloads?
Yeah, so this is managed for you. I'm trying to look for the documentation for this. Kinesis video streams. Trying to find it. I know this is managed. Here we go. So the turn is just going to be available via endpoint that you can call. I'm trying to find what the quotas are.
Let me see if I can find it.
Kinesis video. Oh shoot.
And I assume you can auto scale a turn server the same way you would auto scale a regular like EC2 instance, right? In terms of like monitoring.
Yeah, but I believe it is like it's like one of those managed components.
Okay.
That's why I was thinking we might want to look at the quotas.
Got it. Yeah, fair enough.
Oh yeah, and Mike Lee wants a recording of the previous session, so maybe we can throw in the YouTube link.
Yeah. I'll get that over to you, Mike, right now.
Thanks, Chris. I'm trying to multitask. Okay. Yeah. Okay, so while we're looking for that, so Kinesis video streams, it gives you the signaling channels for those like SDP offer answers. What else does it do? Actually, I'm gonna move this to the left, make it smaller, or is it too small? It might be too small. SDP, you have stun, turn relays, stun, turn. You don't have to build a signaling server. You don't have to manage message routing between these two. And you shouldn't have to manage scaling, which is what we're trying to find the documentation for. And authentication, NAT traversal is managed. So it should be easier to do. And now let's find proof of what we're saying. Okay. I found some KVS web RTC limits, which should help. I'm just going to read through it real quick. And yeah, feel free to ask more questions. Okay, where is turn? Turn service quotas. Here we go. Found it. Let's see. Following section describes service quotas for using traversal, using relays around that turn. 5 transactions per second. I believe that's what TPS is. Did we describe it at the beginning? Let's go to the top. Transactions per second. Yes. Okay. 5 turn service. 5 transactions per second per signaling channel. And then 100 per region per account. And the bitrate is 5 megabits per second, which we talked about at the beginning of the stream, which is, what is it?
Sure, what was it?
Anyone can answer?
Yeah.
Amount of data processed or transferred per unit of time. Okay. And then there's a couple other things here. So the quotas will give you an indication of like what, how much, how you should design your architecture for your workload. So like, how many people do you expect? How many users? I mean, how many users? How many transactions per second? And for any service quotas, if you're an enterprise customer, typically you can try to look to see if there's a way to increase the quota, but it's not always possible to do so. Yeah, I don't know if how it works. We'll talk about the scaling. But for you who's just building something to start with, I mean, like 5 transactions per second per signaling channel is probably pretty good. Okay. I'm trying to see, is there anything else? I'm going to throw this back over here.
And Mike, just a quick answer to your question. You can join us every 2 weeks on Tuesday at 12:30 p.m. to 1:30 p.m. The next one will be on October 14th, I believe. Just confirm that. But yeah, thanks for joining us today, Mike.
Yeah, thanks for coming. Okay, so maybe if we just talk through the flow, I'm not going to draw out, but okay, we talked about a lot of things, so let's bring it together with the doorbell example. Our doorbell connects to KVS, and we'll call it a signaling channel. And then it says, I am ready. I need listeners. I have my mobile app. And I try to connect to the same channel because I want to see what's coming out, what's coming towards my front door. So the viewer is going to send SDP, a signaling offer, and say like, okay, this is my codec and this is my IP information, or give me the IP information. And there's going to be like some security exchanges that are going on. I don't want to go into those details. And we do that ICE negotiation where we have candidates and all of the requirements that we have. And we try to go through stun. And if that direct connection fails, then we go to turn, and all of that is managed for you via endpoints that you're trying to hit, versus like setting up all the infrastructure you would have to do to maintain these servers and relays. And then if you do connect to turn, it will forward the information to each other. Now, once we're connected and we know where each other are, the doorbell can then use, we'll throw SRTP in there. We'll throw our SRTP secured packets to the mobile device so that we can get the audio and video streaming to the web application. And all of this is supported with like the WebRTC framework, which we know is a bunch of libraries and functions that are available to you to implement this whole concoction. And there's a very common pattern for setting up interactive video. So yeah, give it a try and let us know what you build.
Yeah. And yeah, media is encrypted end to end across the whole flow. So
yeah,
great security wise.
Yeah, and we're managing the fleets of stun and turn servers. You get temporary ICE servers, so there's no infrastructure that you need to manage there. Cool. I think that covers most of it. Are there any resources that we should share? I think there's a good one on, I don't know if you shared it already.
There's video streams. Or...
Let me put it in the chat.
Yeah.
There's one on security, I think. I know we only briefly touched on it, but I think it's a good read. Here we go. Again, it gives you a brief overview of Kinesis video streams, but now that you know like what's involved, you can kind of see how cool it is that that type of heavy lifting is taken away, and you can focus on, okay, what are some of the other mechanics I should think about? Other things we didn't really talk about is like, it's probably a good idea to enable something like CloudTrail for logging all the API calls that are being made. So you can see who accessed the stream, or from where did they access the stream, when did they access the stream, all that scaffolding when you're thinking about building a production grade system. I think this blog is good because it'll go a little bit more into detail about encryption, like where that happens. There's encryption in transit. Some of the some data may land somewhere and it needs to be encrypted at rest. For example, I think we talked about in our earlier example when we talked about like this clip VOD pipeline. Obviously, when your input videos are recorded and land in S3, you want to use a key like with KMS to encrypt your data. And then similarly in this S3 bucket, you want to make sure once the transcoder service is done doing what it needs to do, you also encrypt those videos as well at rest.
Yeah. Also, the blog goes into a bit about compliance and privacy. So, right, you can trust that nobody, not even AWS or an ISP, can be able to view any like the video feed. And then, of course, like for a compliance perspective, depending on the types of applications you want, if it's like a more of a financial or health application, have like HIPAA certified and GDPR in terms of compliance as well. So definitely a full, great blog post just to go through and read and digest as you look to build your own.
Yeah. Oh, while we're on this diagram of the VOD pipeline, I actually wanted to mention. So one of my customers actually was interested in an event-driven architecture exactly like this. And then when I drew it out, they were a bit confused because they're like, "Wait, so you're saying you process the file out of SQS?" And I was like, "No, actually, you think of SQS as like storing the event that the processor like picks off the message, and it's like a instruction list, right? It's like what you have in the message that lands on SQS would be like, this is the file, and where this is the link to it in S3, and this is the information I need you to do with it. Here's some other metadata. So it's like a instruction set and like pointing you to the location where the file is. So this transcoder service is picking off the message so it knows what to do, and then it will actually go to S3 and do the thing it needs to do to the file and land it here. And usually that's not something you might see in like an architecture diagram because the arrows get too messy, but essentially that's what's happening. One other thing I wanted to mention while we're talking about that event-driven architecture is the idea of like a ledger, right? So I know we have DynamoDB just sitting out here hanging out, but it could be like an important component like every step along the way. So you record like this transcoder service picked up a message and then process the video, but like in between it might be a good idea to like write intermediate steps in DynamoDB to say like, oh, this file status is now processing, and then once it's done you update that ledger and say like it's done, and that way you're like separating a lot of components, so if anything breaks down anywhere it'll be easier to debug what happened, right? So SQS, you could see like, oh, this message wasn't processed and it ended up in the dead letter queue. Okay, what do I do? I can look at DynamoDB and be like, okay, it looked like the transcoding service is trying to do this and then it failed. And then it wrote like failed and failed reason. So easier for debugging and stuff like that.
Yeah, especially when it comes to, I would guess, like replaying back and reproducing events. You can always go back to the ledger and try to catch up. And I guess it inherently makes your systems more fault tolerant.
Yeah. But yeah, Tino's exactly right. I think oftentimes a lot of stuff gets lost in the sauce in a high level architecture diagram. So it's nice to call it out.
Yeah.
We finish in 3 minutes, actually.
Yeah, it's 12:30 Eastern time to 1:30 p.m. Eastern time every 2 weeks on Tuesdays. Yep.
Yeah, Chris, do you want to go over what we're gonna try to tackle next week, or next week?
Yeah, it's still I guess it's still being fleshed out. We're going to have some surprise guests that very tenured in the space right now that work with us on the AWS side. I'm still kind of fleshing out what the exact demo will look like, but we'll have a couple special guests join us for next time.
Awesome. And we'll remember to throw on the lo-fi again. I forgot to do that.
Yeah. And then feel free if there's any other like pivot that you potentially the rest of the people watching want to see in the future, can always look to see what we can be able to come up with in the future as well. So thanks all for the participation.
Yeah, with 2 minutes left, spam ideas. We need content.
Yeah, spam ideas. Yeah. So we have a lot of essays and engineers, obviously, that we can be able to tap into to discuss or even showcase any full-fledged type of workflow scenarios as well. So definitely flexible in terms of what we can be able to show. Yeah.
All right. Wait, it's not too late for me to throw on the lo-fi. Let's see.
Got a minute.
Do I have the controls to do that? Oh, here we go. This will lead us out.
All right. I can't hear you now.
Oh, you can't hear me? It's too loud?
Oh, now I can. Yeah. W stream. Thank you, Tino.
Thank you, Tino. Oh, wait. How well does third-party software? We love it. We have so many partners built on AWS. So many partners, ISVs, third-party software, hand in AI.
I like how you're typing this out. Zapier is great. I actually use Zapier myself, like personal use, but I like end-to-end Zapier, make.com for like, automation workflows.
Yeah. AWS pretty agnostic on LLMs. OpenAI available on Bedrock. So feel free to try that out as well.
All right. Thank you, everybody. Catch you next time.
Thanks, everyone.